are black holes? Holes that are black? Hi, I'm Zenah, student empowerment expert, and today I'm going to talk about a very interesting and mysterious subject, black holes. Black holes are a region of space and time. It's like 3 or 4 suns fitted together in a tight little box. This tightness creates a gravity, and that gravitational pull is so strong that not even light can pass through. If you were trapped, you would be stretched into spaghetti. And if you wanted to escape, you would have to travel faster than light, which is, oops, not possible yet. See, Einstein predicted how black holes could form. If a very massive star dies, it creates a supernova. The most massive of stars are eventually overwhelmed by their own gravity, which crushes them so violently that they collapse into a pinprick to create a black hole. In just one sentence, I can say that when a star dies, it creates a black hole. However, it is not that easy. I will explain the death of massive stars. Stars are 8 times more massive than the Sun end their life in strange and frightening ways. The heat and pressure inside the core of a star becomes so huge that nuclear fusion can not only fuse hydrogen atoms together to form helium, but can also fuse helium and larger atoms to create elements such as carbon or oxygen. As this takes place, the star swells into the largest star of all, a supergiant. You can't even imagine a supergiant, or I can't. The star grows into a supergiant. Nuclear fusion carries on inside the core, forcing atoms to form heavier and heavier elements until the star's core turns into iron. When this happens, the core no longer generates outward pressure to resist the crushing force of gravity, and the whole star suddenly collapses, causing a catastrophic explosion, a supernova. A supernova is an explosion of stars. The star self-destructs in the explosion brighter than 1 billion suns. Its outer layers are blasted into space, but its massive core continues to collapse on itself. What happens next depends on how massive the core is. A smaller core becomes a neutron star. It's up to 3 times bigger than the Sun, and one fun fact: 1 teaspoonful of the material in the core of the neutron star weighs 5 billion tons. Coming to the massive core, it never stops collapsing. It shrinks and shrinks until it is 1 billion times smaller than an atom and becomes a black hole. So this is how a black hole is formed. A black hole is a place in space where gravity is so strong that not even light can pass through. Well, one thing can: subatomic particles. A black hole has an event horizon in which we call the point of no return. Well, our word says it all. An interesting fact: black holes aren't actually holes. They are a huge amount of matter crammed up in a very small, in fact, zero space. Being this much compressed gives them an extremely strong gravitational pull, and that is why it sucks everything down. Okay, so when you look at a black hole, what you see is its singularity, which has infinite density. It is not yet found which particles they are made up of. Astronomers have finally come up to the fact that there are 2 types of black holes: stellar mass and supermassive. Stellar mass black holes are up to 20 times more bigger than the Sun. However, supermassive black holes can be about 1 billion times massive than the Sun. The largest found black hole's name is S5001 plus 81. It is 40 billion times more massive than the Sun, and it has a diameter of 236.7 billion kilometers. So what's the temperature inside a black hole? It is freezing cold inside a black hole. The internal temperature of the mass of our Sun is around 1/1,000,000th of a degree above absolute zero. They emit almost zero radiation, so they are very cold. They are net absorbers of CMB photons that have an average temperature of 2.7 thousand. Since heat flows from a hotter body to a colder body, black holes are colder than that. On the outside, they have neutrino particles hitting each other and radioactively heating their neighbors to millions of degrees. Then there are these huge clouds of radiation, those mysterious dense objects. They are Hawking radiation and they form magnetic fields. Black holes evaporate away very slowly and then get faster because the black hole will get smaller. This is called Hawking radiation. When it's the mass of an asteroid, it radiates around room temperature. When it's the mass of a mountain, it radiates around the heat of our sun. And at last, the black hole evaporates away with the energy of billions of nuclear bombs in a huge explosion. However, this process is extremely slow. A normal black hole can take about a Google year to die. And how much is that? This 1 year, followed by 100 zeros. So who knows, maybe at that time our whole solar system will be dead. Thank you.